Here we have the graph of sine of x between minus 90 and 360. So for which values of x is a f of x greater than or equal to 0. So a is asking for where this graph is above the x-axis, and that is over here. So that is when x is greater than 0 but less than 180. For part B, we want f prime x greater than 0. Now, when they talk about f prime x, we are talking about the first derivative. So we want the first derivative to be greater than 0. Remember, when we talk about the first derivative, we are talking about the gradient. So we want a gradient that is greater than 0, meaning that we want a positive gradient. So where is the graph? So where do we have a positive gradient? It's also where our graph is increasing, right? Because if our graph is increasing, it will have a positive gradient. So we have a positive gradient over here and over here, right? So our answer would be between minus 90 and 90. So it is when x is greater than minus 90 but less than 90, or it is when x is greater than 270 but less than 360. And then for C, we want x times f of x to be greater than 0. This x times y to be greater than 0. Remember that f of x is the same as y. So we want, when you multiply an x value with the y value, we have to get a positive answer. Meaning if x is positive and y is positive, we get a positive answer. Or if x is negative and y is negative, we get a positive answer. So first, let's look for where we have positive x-axes. So our positive x-axes are right here. And then now we have to look for where f of x is positive, meaning that f of x is above the x-axis, and that would be over here. So then our answer would be between 0 and 180. So the first solution would be when x is greater than 0 but less than 180. Now the second part could be where we have negative x values as well as the graph being below the x-axis. So where do we have negative x values? On this side. And then where is this graph below the x-axis? That is here and here, right? So then if we look at this, on this side, we have a positive x values, negative y values, so that does not give us a positive answer. But then over here, we have negative x values and negative y values, so that gives us a positive answer. So that is between minus 90 and 0. So our second solution would be when x is greater than minus 90 but less than 0. Okay, let's take a look at a second example. So for the first question, we want f prime x to be less than 0. Remember that f prime x is the gradient. So we want a gradient that is less than 0. So we want a negative gradient. So where do we have a negative gradient? When the graph is decreasing. So the graph is decreasing over here and over here. So let's say this x value is 1 and then this x value is 5. So when is our graph decreasing? Our graph is decreasing when x is less than 1 or when x is greater than 5. Right, so for the second question, we want x times f of x to be greater than 0. So x times f of x to be greater than 0. So x times, remember that f of x is y, to be greater than 0, meaning it is positive. So we can have positive x values and f of x can be above the x-axis, or we can have negative x values and f of x can be below the x-axis. That will also give us a positive. So firstly, let's look for where we have positive x values. This is where we have positive x values. And then let's look for where this graph is above the x-axis. So it is here and here. So now at the same time, where do we have positive x values and the graph being above the x-axis? It's between 3 and 7. So our answer would be when x is greater than 3 but less than 7. And then the second case would be where we have negative x values. So this is where we have negative x values, and then where the graph is below the x-axis. So the graph is below the x-axis over here and here. So this scenario right here does not give us a solution because there is no place where we have negative x values and the graph is below the x-axis during the same time. So our only solution for this question is this one right here. Now C, we want x times f prime x to be less than 0. Remember that f prime x is the gradient. So if something is less than 0, that means it is negative. So we want positive, we can have positive x values and a negative gradient. That gives us a negative, or we could have negative x values and a positive gradient. That would give us a negative also. So firstly, let's look for positive x values. This is where we have positive x values. And then let's look for where we have a negative gradient. Where do we have a negative gradient? When the graph is decreasing. So our graph is decreasing right here, as well as right here. So then what is our solution? We can see these two pieces between 0 and 1. So that would be when x is greater than 0 but less than 1. We can also see from 5 all the way to infinity. So, or when x is greater than 5. And we can also have a case where we have negative x values, and that is here. And then we have a positive gradient. Where do we have a positive gradient? When the graph is increasing. So the graph is increasing right here. So in this case, this scenario right here does not give us any solution because we do not have negative x values and a positive gradient at that same interval. The only solution for this question is this one right here.